Greetings, the Astro 30 here, yet again, and welcome to part 4 of this AEL480 stereo amplifier build. Now, I've just received a package from Ultronics today, which I ordered on Tuesday, I think it was. It's now Friday. So I went with, 3-day maximum express via the air. And it's just a set of components to continue this project on. Okay, so they've put a paper, jiffy padded bag on the inside of a post bag. So it's a double bag, which is nice. I wonder why it felt so stiff. You know what I mean? And I had an accident with a cup of coffee yesterday morning. I knocked it over on that desk there and it went everywhere, and I mean everywhere, including places that it shouldn't have. Still a bit pissed about that. But the rack case box was actually still sitting on the desk at that point, and as you can see, it's soaked up a majority of that coffee. And the two panels, the top and front panel, are still in that box, but they survived. So too did the DeLorean, because it was sitting on top of all that stuff. But I was not happy, Jan. I was swearing and carrying on around about 6:30 yesterday morning, cleaning up the mess. Anyway, moving on. So, what do we got here? Alright, well, first off, we've got an IEC female power socket. I'll have to look at how I'm going to do the earth. I'm going to solder the wires, active and neutral, or live and neutral, onto the pins themselves and then insulate them. There's also a couple of these insulated M205 fuse sockets, PCB mount, with a little plastic cover. That's going to go on the power AC adapter board that comes off of this thing, goes through a switch and a fuse. So the fuse is going to live on the PCB with a cover over it to protect from accidental electrocution. So that's nice. What else have we got? I know what I've ordered, but I don't remember offhand. Got a set of these large crimp pins. I've got 60 of them. They suit these style of connectors. Even though you can buy them from JCar with the crimp pins with it, but it's always good to have spare ones, because when you're crimping, you can run a fairly high probability of destroying a couple of the crimp pins when you're doing it, or the wire just pulls straight back out after you've crimped it, and then the crimp's useless. So you need to use another pin. So I've got 60 of them. I have 60 of these smaller ones, which suit these style of connectors. Again, JCar sell them with the crimp pins. However, if you buy these from Ultronics, they do not. They're sold separately, which is why you can get them separate. Again, for the same reason, if you do a crimp and you destroy the crimp, or the wire pulls back out the crimp's useless, you've got to re-crimp it. So again, it's good to have spare ones of them. I pity the poor sod that had to sit there and count them. But there's 60 of them. And I think there's just one more thing in here. Yes, there is. A piano key style 2 output speaker terminal. Now, some may argue that these are crap, and audiophiles will tell you that they add distortion and really shape the sound, and they're no good. Well, pardon me, but that's bullshit. The only thing that can affect these connectors is the amount of current running through them. Too much current and, well, things start to melt. And also a headphone socket that I'm going to need for the headphone board. So yeah, pins are a bit bent. So those are the components that I've got, so I can now continue on doing the rest of the construction of this part of the amplifier, which is making it in a working, usable state. That is, you can actually apply power to it, turn it on and off with a switch, and connect it to a set of speakers. So that's what I'm going to be getting on in this video. I'm still waiting for the PCBs for that. They're not here yet, so this video will be probably 2 weeks in the making. Anyhow, that's my little parts list here today, and I've just noticed something. This socket comes with a padded thing on it. It looks like it's actually stuck to it. Oh, that's interesting. I mean, I might leave it on there so that it's like, you know, got to the back panel, and so it's like got some cushioning, I suppose. I mean, don't know what the purpose of that is. Anyway, that was interesting. I don't have a plug handy. Anyway, yes I do. I was going to use one of these little 3.2mm connectors just to make the connection to the socket. See, they fit on there reasonable. They're a tiny bit loose, but they'll do the job, and they come back off. So that's the main thing. Anyway, on to doing some constructive stuff, and I might actually drill the back panel to accept the socket, which is really poor quality, and also the power socket. So that one's going to be fun to cut out with a Dremel. So what I might do there is I might just like drill 4 holes, large holes around the outside corners of this socket, so that the blade of the Dremel has something to come up against without overcutting, because yeah, overcutting the hole would be nasty and look terrible. So yeah, let's get on with doing something constructive. Now I've run into my first problem with this, of course. This 4-way speaker terminal socket, this one's from J-Car, but it's the same as the one from Ultronics. It just doesn't have that backing thing on it. These pins are awfully close to this edge. There's about 4mm between the pin and the edge, which is going to make it awkward for me to drill a reasonable size hole where these pins aren't actually shorting on the metalwork. So these are a little bit different than what they used to be made. I don't know why. There are 2 solutions. I can use a large square cutout around the inside of this terminal where my fingers are, and then mount it from the inside of the panel, which is what you're supposed to do. Or I can just Dremel out a small slot where the pins are by drilling 2 5mm holes either side where the 2 pins start on either end, and then cut a slot just so that it can pass through the panel from the back, and it will look less messy, because as I'm using hand tools, when I cut out the hole, it's going to look rough, ready, and kind of ugly. So I want the socket itself to cover up where I've made the cuts. So I've done a lot of measuring and piss farting around, and I've got roughly where I need to drill the holes and cut the slot. I do have the mounting holes marked, but from where I was looking at it sideways like this by lining it up, it doesn't look like the holes line up. So I'll make sure before drilling these holes that you know, everything lines up. The IEC socket, on the other hand, is going to be pretty easy to do. It's just one square cutout. So I'm going to measure in 2.5mm from every corner, mark where I'm going to drill a hole, and drill another 5mm hole on each corner, and then cut the slot out. So that's going to be my task for today at the moment. So something like that is what I was going for, and yeah, the pins come out the slot just nicely. However, it's very hard on the tool. It took me half an hour just to cut out a small slot, and it ain't sounding the best now. That sounds terrible. Actually, I might try taking out the actual cutting blade and see if it is actually the bearings inside this machine or whether it's something else. Let's try tightening that back up again. Interesting. It's like the center was coming out. Whatever. I think that'll work out perfectly fine. So the pins are actually away from the metalwork. The whole centers line up okay. It's not crooked or anything. See, I think that'll do just perfectly. So all I've got to do now is do this sodding hole. I might have a smoke first. That actually worked out better and quicker. I ended up drilling a bunch of 3.5mm holes around the perimeter inside edge of the hole, and it only took me about probably 5 to 10 minutes to actually cut it far enough so I could get a screwdriver in there and just break it out. So yeah, it looks rough, but all I've got to do now is just file it. So I'll get to doing that and then see if the socket fits. Yeah, the panel's a bit grubby, but that'll clean up. That's just where the masking tape was. But that does fit in there nicely and the holes line up, so that's the main thing. And it looks straight. So I'll get to actually screwing the hardware onto the panel. Got a bit of a dag here. Oh, it's a hair. Alright. I'll get to screwing the components on. I'm going to use the socket that I got from Ultronics. Just because, well, yeah. And then I'll apply it to the back panel. Well, apply the back panel back to the amplifier. That one fits alright. It's not interfering with anything. I don't like the fact that that rubber back is on the connector, but I might end up taking that off. I think the reason they have that on there is for when you mount it to a wooden cabinet like a speaker box so it doesn't vibrate the connector. That's my only thought, but why you would use a 4-way connector on a speaker box is beyond me. But it could be on something like a subwoofer, so yeah, there is that. The IEC socket's in, it's already got its connections on there. I've shortened the power switch it leads, so I've reused that one. Clears the transformer. It's only coming into contact with the body of the transformer because, well, the way it's heat shrunk. Once I put the PCB up here for the fuse board and switching circuitry, how basically to connect the socket to the power switch to the transformer. Yeah, this will sort itself out, so that'll be fine. Here's the switch leads down here, which have been shortened. So if the PCB goes up here, which it will do and will fit nicely, yeah, box of birds. Just got to remember I've got to leave 10mm from the top of this panel and any holes and stuff that I drew on PCBs so that the top panel does not interfere with like standoffs, etc. And those jumper leads just go to the relay output for the speakers, so I can actually hook it up to a pair of speakers on the desk here to just use it in the meantime, which I have been for the last week and a bit now, and it sounds alright. And this is the ground lead for the power socket, so that just plugs in at the bottom there. I just haven't plugged it in at the moment because, well, 1, it's not needed, 2, it's not hooked up to anything. Alright, so I guess the next thing to do is to move on to the PCBs, like the switch board PCB I just mentioned and the headphone socket board. I'm not going to drill any of the front panel yet until I've got the preamplifier and the switch selector board there, which I don't have yet. I haven't even laid that one out yet. But the preamp is already on the way. And yeah, I'm still currently waiting for the other 2 PCBs I need, so this is why I decided to, well, I might as well do the hard part of this project, which is cutting these bloody square holes out, so, and then solving the problem with this socket, which is what I've done. Alright, so we'll move on to the next thing. Okay, and after a couple of weeks, actually it's been longer than a couple of weeks, the PCBs I need to actually progress in the construction of this amplifier have arrived. So I will just open this box without any further ado, and oops, nearly cut my thumb. I'm doing it this way because, well, I haven't masked out my address on the front of the box because I couldn't be bothered. And here are the PCBs here. So we have got our headphone adapter PCB. So that allows the speakers to be disconnected as the plug is inserted, and it also has the required current limiting resistors to drop the level of the output of the power amp down to headphone level. I've got positions here for two poly switches, which basically are poly fuses, and just in case the output is ever short circuited, there's no short circuit protection on the amplifier, so that adds short circuit protection there. Some audiophiles will say that it's basically like putting a normal fuse in line with the speaker output. Adds to the distortion. Well, yeah, that's debatable. And I've used really large footprints here for the 1 watt devices, which is good. And there's a position here for a resistor and an inductor, which the inductor will be wound over the body of the resistor. That will be that coil I was talking about. So this has a inbuilt inline fuse so that it protects the transformer from, if the transformer ever has a fault, it protects your wall socket and your switchboard or fuse board from blowing fuses. I got 10 of these, I think it is. 1, 2, 3, 4, 5, yeah, 10. And that's what that looks like. And we've got a place here for a fuse, which I have a fuse which I bought from Electronics a couple of weeks ago, fuse holder. And I don't know how well that's going to fit in the footprint, so I'll have to have a quick look at that. So here's the fuse holder in question. And, well, it does fit through the holes. Unfortunately, as this board was not really designed for this particular type of fuse holder, it does bend the pins over at a slight angle. However, I think that's going to be perfectly acceptable. I mean, it is, yeah, putting a little bit of stress on the pins, but I think I can get away with that. I was originally thinking, oh, I'll just drill the holes out, to say something like 1.5, 2 millimeters or something, but I don't think I have to. I'm going to leave it like that. That's perfectly acceptable. And the little cover that goes with that fuse holder should actually fit over the top of it without any issue. Yeah, fits perfectly. Cool. Well, there we go. So as I've got the fuse holder now in there, I'm going to leave that in there prior to soldering and come back to that later. So that's for the switchboard to make the power switch of the amplifier actually do something. And that leads us to this final packet of PCBs, which I added at the last minute. These. Now you may be wondering what this is for. Well, that heatsink, when running the LED on the power switch, is getting way too hot. So it's got to dissipate about 700 milliwatts. So yeah, it's going to get pretty hot. Which means I'm going to need a bigger heatsink. Wait a minute. Okay, let's see what we can do about it. Really? These didn't last more than 2 months. Why can't I have another pair? Well, enough farting around. This is so I can mount a transistor with some fly leads or a connector or whatever off back to the main power supply PCB, so I can take that series pass transistor and mount it to the main heatsink to solve the issue of heat. Because as I've been running it, I've noticed that that heatsink on the power supply board is getting quite hot. So in order to dispel that problem, I've just had this little PCB made up, and I'll put a 3-way connector in place of the BD139 transistor on the power supply board, run a cable up to here. I'm not going to put a connector here, even though it's designed to have one. I'll just hardwire it to the board, that's fine. And I'm going to use a TIP41C instead, a TO220, and bolt it directly to the heatsink, and then plug the other end into the board. And that'll solve the issue, because there's a big chunk of metal there, might as well use it. And I got 50 of these bastards. Why? I don't know, because I might find a use for a little PCB like this where I need to mount a transistor to something. Alright, so that's what I've got going on at the moment. Now, I don't have enough time today to deal with the heatsink, because I've got to take the amplifier back apart, pull the heatsink out, to drill it for one, and I'm probably going to take those screw holes, 5 screw holes on each bracket that the power amps mount to. I'm going to tap them out to M4 so that I can put screws in from the back, so I'm not using a screw and a nut. I might as well, and I'm going to drill and tap that hole for that PCB. But what I am going to do is I'm going to assemble up this PCB today, just to get started, and test it out, because I've already got the wiring there ready to go, all crimped. So I'm not going to take much footage of this. I'm just going to take snips along the way, especially when I get to these inductors and resistor combination. So that's what I'm going to be getting on with now, once I find some space on my desk to put stuff and start working. So I'll catch you in just a bit. Alright, and a short time later, probably about 20 minutes of screwing around, I've actually got the board assembled for the most part, apart from the resistor inductor combination. Got the polyfuses in there, RXE250s, and they work fine on a 100-watt amplifier. The trip current is, I think, around about the 5 amp mark, and the continuous current's 3.5, so that should be fine enough for the purposes I'm using it for. Now, I'm up to the stage of winding the coils around the body of these 10 ohm resistors prior to soldering them in, and then we can test it. I was going to say something else, but I can't remember what it was, so we'll forget about that. So what I've got here is some 0.4mm diameter enamel coppered wire, and I need an inductance of around about 0.7 microhenries. So that equates to around about 10 turns on the body of this resistor, and it's chosen at 10 turns is because it's about the only amount of turns that will fit on there. So what I need to do first is I need to, bare the end of this piece of copper wire, so I can then terminate it, soldering it at one end of the resistor, and then wind it and then do the other end. So I might just use a knife for that to scrape the enamel away from the copper wire, because that's probably the easiest way to do it. And then when I heat it with the soldering iron to tin it, that should remove off the rest of the copper. So a piece of sandpaper works just as effectively. So I'm going to see if I can tin the end of that now, prior to wrapping it around the body of the resistor. Didn't realise my soldering iron had gone to sleep. It's very awkward to do this on camera for a start, but that looks like it has tinned, so there goes the wire straight onto the floor. So I can then solder the end of the wire to the body of the resistor, or the leg of the resistor I should say, like so, and then I can begin to wind. So it's probably going to be easier to wind this out of the jig, or at least one end of it out anyway. So which way to wind it? I think I'm going to go with the 10 ohm bands facing to the left as you read it. I think I'm going to go round in that direction. So that is 1 full turn, 2 full turns, 3 full turns. I'll just shove them down the end there. 4, 5, 6, 7, 8. Yes, I can count. 9, and finally 10. So that's 10 turns of 4mm copper wire over that. So now what I have to do is I will make one final turn to pull it off, and well, I need to scrape off some more insulation or enamel. So I might mount him back in here. I mean, I could, you know, cut the video, but it's no fun like that. Hopefully I've scraped off just enough to get it to tin. I'll soon find out. Because sometimes even the heat of the soldering iron is enough to melt the enamel. And that looks fine to me. So to finish this off, I can then wrap that around the end of the resistor like that. Solder him off like so, and then I can trim my wire off and then trim. That's still hot too. I might take it out to do it. Trim that little bit of excess off. Bingo! One resistor and inductor. Isn't that special? Doesn't have to look pretty, but now I've got to do that twice, or I need to do it a second time, I should say. I'll do that off camera because it's boring enough as it is, and then I can solder them into the PCB. Alright, 2 identical coils. So for low frequency up to, you know, audio range anyway, this should look like a direct short circuit anyway to those signals, and at frequencies above 1 megahertz or so it should be quashed out by the resistor. Just make sure we've got continuity through it, which we do. We've got about 0.8 of an ohm, about 0.8 of an ohm there, so that one's fine as well. Alright, as precarious as that is, the PCB is actually cable tied to the rail up here so it doesn't move around and short on anything. This is only temporary until I actually drill the front panel. Just got to be mindful of the voltages that may be present on the back of this PCB and don't brush up against it when getting drunk. So in this current state now, the speaker wires coming off the relay into here go through this circuitry, through the DPD switch of the socket, and then back out through these wires to the speaker connector at the back of the unit. So at the moment it should be a direct signal path right through. So I can prove that by plugging it in and play an audio track. Everything seems fine so far. So play any audio track, it doesn't matter. Well, I hear some sound. Although that's better. That track I played was heavily over panned to the left. That one sounds panned as well, so sounds like it is coming out evenly. far as I know it is. It sounds like it. Alright, so without wearing the headphones, I'm going to plug it into the socket. And, well, I don't hear anything coming out the headphones. Now I do. But it's actually quite a lot more attenuated than the speakers, which I guess in a way is fine. It just means I probably have to change the values of these resistors, etc., just to balance it out a bit better. But in the interim, I know I'm just going to kill that because that's kind of annoying. Yeah, right. In the interim, that is working fine. And if I short-circuited the speaker terminals, it's not going to blow the fuses on the PCB of the power amps. So I know that this board is functioning. So now all I need to do is, well, do some sound tests later when I'm bored. And yeah, but what I'm going to do now is I'm going to move on to pulling this heatsink back out, dealing with that heatsink down there, that transistor, and wiring up the mains board so that I can actually use the power switch to turn the thing on and off as it's supposed to. I'll do that all tomorrow though, because I don't have much time now. I've got to start thinking about getting ready for work, which is about now. So, alright, I'll see you again tomorrow. Good morning, it's the next day, and I've pulled it apart, and I've already gone ahead and I've tapped out the holes that I need to M4 for the power amp modules and M3 for the transistor. Each bracket has been drilled out to 4.5mm just to give it a little bit more wiggle room. And I've already gone ahead and mounted a TO220 TIP41C transistor and cabling to this PCB so that can go there with an isolator. So now I've got the task of putting it back together. Well, this is so much easier than the way I was doing it before. I've mounted the transistor to the heatsink and it is very close to this bracket that I'm screwing up now, but I just did a continuity check and it is actually isolated from the heatsink. So, well and good. There's a good probably 1.5 mm gap between the edge of the bracket and the transistor, so as long as the transistor's put in square and not at an angle, yeah, it should be fine. It's much of a muchness considering because of how long this heatsink, because it's 250mm, so you're not going to get dead center in the fins here because there's a fin there. So there's no hole directly in the center of the heatsink, or gap in the center of the heatsink, so you can actually get a screw in the middle so that I could move that over, 5mm. So that's not going to happen, but that's alright. So these modules actually fit a lot better with the screws that I'm using than they did with the M3 screws and nuts. So I'm quite happy about how that is. I'm not sure if it's straight, but again, working with hand tools, you're not going to get it perfectly straight, so there is that. So I'm just going to make sure that all the screws are tight, so there's good mechanical contact with the heatsink, which they appear to be. And now I will go ahead and do the other module, hook all the wiring back up, and come back in a second. Okay, all tightened and all the wires rehooked back up. As you can see that transistor is very close to that bracket, but it should be isolated. We can double verify that. I'll just put that on there like that. Nothing. Screw to bracket, continuity, but actually transistor to heatsink, no, it's isolated. So that is all that is necessary, even though it is very, very close. Now it's time to turn my attention to the power supply and remove this old transistor and heatsink combination here, put a connector in the correct way round so that this new transistor can plug into it. And then on a dim bulb we can test that the thing still works. And then I'll move on to the next part of this video, which is making the power switch actually do something. Module is out, and whilst I'm at it, I'm going to change this 47 microfarad capacitor to a 220 microfarad capacitor. Mainly because when the light is flashing on the front, on the power switch, it looks a little bit unusual, as it would if it was on a completely smooth DC power supply. Plus that is getting kind of warm as well on its own, so I'm going to upgrade the cap. It just means that the relay, when it actually gets turned off, will drop out a little bit later than it would with the current capacitor. But with a little bit more smoothing, the transistor that's going to be connected in place of this will have less ripple to deal with, and I'm hoping that'll stop it from getting as hot. But yeah, that's probably unlikely, but I'm going to do it anyway. Alright, the modifications are done. The power supply module is back in its home. I've got everything all hooked up. I've got the wiring from the transistor socket and the transistor board on the heatsink here tied to the top of the rail to try and keep any mains noise that may be present through these wires because of magnetic influx away from the signal wires as possible. There is a new 220 microfarad capacitor in place of that 47, so now I'm going to turn the dim bulb on and we'll just see if it still works. It's flashing a lot better too. And there we go. So obviously the transistor is functioning, it's not shorted to ground, and there's no current draw on the dim bulb, which is good. So right where the transistor is, I'm going to feel it, if I can get my finger in there. Can't feel anything yet. I mean, it is starting to slightly warm up. But now that it's on the main heatsink, it should actually be fine now. I don't have to worry about it overheating. Because I don't know what's going to happen in summer when the ambient temperature in the room's a lot hotter. Whether that's going to affect that tiny little heatsink that was in there to start with. But so far, everything is functioning. I don't know if the power amps still work, but well, they should. I could quickly verify that. Well, the right hand channel works and the right still works, although I just broke my header pin that connected the wire to the power amp, but I can fix that shortly. I'm not worried about it right now. I probably have to take all the heat shrink off and start again, but that's alright. This cable's not going to be used anyway. I'm going to redo it. So heat wise, it's perfectly fine. So okay, I can turn that off now. There was a slight longer delay for the relay dropping out, that's fine. So now I can turn my attention to the power switchboard, which I already have assembled here. All I've got to do now is just drill holes on the back panel to accept it and then hook it all up. So that's going to be my next task. And a short time later, there is the board there, all screwed into the back panel. And that's probably the first PCB that I've actually measured the hole centers with a ruler, rather than just drawing around the inside of the holes. And it actually came out perfectly fine. Tiny bit off here and there, but in general it fits perfectly. It's straight and it's square with the panel, doesn't look odd, and these wires are just long enough, so it's all perfect. So now I can put it back in the case, hook it up, and I have to modify all this crap. It is unplugged. Modify this crap, get rid of this, and actually put some spade terminals on the end of the transformer primary windings or wires, so it can be plugged into the PCB. So I'll get to doing that and we'll come back when it's actually all back together. Penis. Okay, so I need a IC cable. Okay, so I've got the transformer crimped. I'm going to first, before I connect it to the PCB, is just make sure that we've got continuity from the live through the circuit and out the live pin here, and make sure that the power switch actually does its job. So with the power switch currently off, I'll hook across live. That's the live out there. Nothing. Turn the switch on. We've got continuity, so I know that that's fine, and if I go across the pins there's no short circuit, so I can actually now hook in the transformer, which is going to be kind of messy at the moment until I've finalised everything. If I can get the thing in there. There we go, that's the neutral. Actually I might go move that ground around to where it should be, which is down there. It's sort of like, because the panel's not quite, I'll fix that later, I've got to pull the panel off again anyway. So the ground is actually connected to the power plug now, so I can demonstrate that we are indeed grounded. So we shouldn't have a short circuit across live and neutral. We don't, but that's saying 13.7 ohms. So, but it will still be because it's pretty low ohms. But 13.6, 13.9, somewhere around there, that's perfectly fine and safe to plug in. And now we'll see if it works. Power switch is off. Dim bulb is now on. Turn it on by the switch. Isn't that lovely? So everything is now able to be turned off with this switch, which is, well, the whole entire point of the power switch. But I know there's no unusual current draw on my dim bulb. There's nothing happening, so I know it's safe to take off the dim bulb and hook it up to some speakers. So I've got to connect them back up because I haven't done that yet, but I'll do that. I've got to fix this stupid wire. I might just put a PCB pin header on there and just not bother heat shrinking it, because I'm changing it anyway. So let me just quickly fix that up so I can re-establish the audio connections and we'll come back. Right, it's really windy outside. Everything is now connected up, speakers, etc., and it's off the dim bulb, so I'm going to turn him on and I'm going to play a track through it, or part of a track. Perfect. Let's try this one, see what that is. Sounds alright. Let's play something else that's well, something that I know. I don't really like that track. Sweet. It's coming out of both speakers evenly. I'm not going to turn it up any louder because I've got it set on that pot that's hanging off the edge of the case there to a level where it's reasonable I can use it at night. Perfect. So that's where I'm going to leave this part of the video, or this part of the build, because the next parts that are going to be done are going to be the preamp. I'm going to put the sub panel back on in a minute. It's going to be the preamp. Someone did comment on one of the builds, do not include a preamp because it adds noise and hum and etc. Well, yeah, that comment does have merit, but at the same time, it's debatable. Anyway, if you'd like this video, please remember to go down below and comment, like and subscribe if you haven't done so already. And this is the Astro 30 saying, as always, see ya, have a great day, I'll see you in the next one. Thanks for watching.